Hello students, welcome back to our AriserTalent. I'm your maths teacher, Arpita Sharma. We are studying this chapter, Arithmetic Progression, AP. Okay, so we'll just start this chapter by writing the name here, AP, Arithmetic Progression. This is our chapter and we have gone through little basics of our chapter and we were on this topic, sum of and terms of an AP. So the formula was not Sn but Tn. Okay, Tn, our Tn was the nth term, that was a plus n minus 1 d. Okay, that was the formula for a term, nth term of AP, and sum is n by 2 2a plus n minus 1d. Here 2a. Okay, a plus n minus 1d, that was a formula of nth term. We have just n by 2 here added and we have added a 2 in the multiplication of a. This term can be written as n by 2 and we can write this 2a as a plus a n minus 1d. Okay, and this is what? A plus n minus 1 d. Now, this can be written as n by 2 a plus. This is what we have, our Tn is. Okay, so Tn here, a plus Tn. So, we can use this formula or this formula. So, we are having two formulas of Sn. We just can convert this formula into this formula of Sn in the form of Tn. If the direct value of Tn is given, then you can apply this formula also. Okay. Understood this concept? Now, if sum of n terms Sn is given, then general term Tn is equals to Sn Sn minus 1. That means the last term minus the second last term, that will be your Tn. Sum of the last term minus sum till second last term will be your Tn. That means if you are having an AP 2, 4, 6 and till you are having 28 and 30. So, this will be your last term. So, if you will be having sum from here to here, this is your let's suppose T15 and sum from here to here, that will be your S14. So, S15 minus S14 will give you what? This 30, the last term. Okay. Can we have an example of that? Okay, let's have a series of an AP of 4 terms, 2, 4, 6, 8. So, if we sum that, okay, just forget about the formula, just sum it up here randomly, so that will be 10 and that will be 10, so that will be 20. So, the sum of n terms, that means 4 terms, is what? 20. And if we talk about these 3 terms, so S3, which is basically, if this is Sn, that will be Sn minus 1. Okay. So, S3 will be what? 6, 4, 10 plus 2 is equals to 12. So, basically, Sn minus n minus 1 will be Tn. This will be equals to this. Okay. So, if you cross check it, 20 minus 12 will be again 8. So, right? Sn minus 1 will be equals to what? The last term, that is Tn. Okay. Now, another term of an AP is linear. Now, focus on that thing carefully. AP, if we talk about AP, if we are having a linear equation, or it can be a quadratic. Okay, we found linear equation only in case of nth term, that will show nth term, that means Tn. And if we talk about the quadratic, quadratic equation in terms of n, है ना? So that will be showing only what? Sum of n terms. That is Sn, right? Whenever a series in AP, that will be having a linear equation in terms of n, and if we talk about its sum, that will be in quadratic terms. Again, if we talk about the d will be the coefficient of n. D will be the coefficient of n. What is d? The common difference. Okay, and if we talk about the quadratic, then d will be 2 multiplied by coefficient of, because it's in quadratic form, coefficient of n square. So the n square coefficient multiplied by 2 will be the common difference when sum is given, and that's always in the quadratic form. And if the nth term is given, that will be in linear form, and the coefficient of n will be what? Your common difference. Okay, so note it, and we'll be having some example of it too. So it's given here, nth term of an AP is linear in n. Example, an equals to 2 minus n. Now in this first one, the coefficient of n is -1 here. Coefficient of n is -1 here. That means common difference in this case, 2 minus n will be equals to -1. In the second, 5n plus 2. Okay, so Tn is 5n plus 2. That means the common difference will be equals to 5. Let's check it. Okay, come this side. If we talk about this one here, that will be T1. That means the first term will be 2, n equals to 1, minus 1, that will be 1. Again, T2 will be equals to 2 minus 2, 0. And then the T3 will be equals to 2 minus 3, that will be minus 1. Now, if you have T2 minus T1, that will be minus 1. That means common difference is what? Minus 1. And now look at this. The coefficient of n is here what? Minus 1. Similarly, if we check this one, the coefficient will be 5. So that means D must be equal to 5. Let's check it. If we'll having this T1, the first term, that will be 5 multiplied by 1 plus 2. If you'll be having T2, that will be 5 multiplied by 2 plus 2. So that will be 5 plus 2, 7. And there it will be 10 plus 2, 12. Now, second term minus first term, that will be equals to 5. Now, 5 is again what? The coefficient of n. That means the coefficient of n will be the common difference of the particular given AP. Okay? Note it. So, verification, we have done this complete procedure. So, let's move forward about the sum. So, here this is given the example 2n square plus 3n. This is the example given to us, and the another example is given Sn equals to, here it's also Sn, n by 4 n plus 1. Okay. So, these two examples are given. Now, if we talk about the first one, so the first one Sn equals to 2n square plus 3n. Okay. So, now here the coefficient of n square, D will be coefficient of n square, which is 2 multiplied by 2. Here coefficient of n square is not here clearly visible, but what can I say, that I can convert this as n square by 4 plus n by 4. So, coefficient of n square is 1 by 4. So, 2 multiplied by coefficient of n square, that will be 1 by 2. So, that will be 1 by 2 here. Now, let's check it. Sn, so that means S1. S1, that means summation of one term. Summation of one term is the term, first term itself. So, S1 will be your first term. Okay, here 2 multiplied by 1 square plus 3 multiplied by 1, that will be 2 plus 3 equals to 5. Now, the second, summation of two terms. Summation of two terms. That will be 2 multiplied by 2 whole square plus 3 multiplied by 2, and that will be 2 to the 4 to the 8. 8 plus 6 equals to 14. Now, S2 minus S1. S2 minus S1 will be what? Our second term. So, S2 minus S1. Now, S2's value is 14 and S1 value is 5. So, that will be 9. So, 9 is equals to what? Second term. 9 is second term and first term is 5. So, second term minus first term. This is what? Common difference D. So, put the values here. This will be implying that D equals to the second term is 9 minus the first term, which is 5, and that is equals to 4. Okay. Now, common difference equals to 2 multiplied by 2, 4. Okay. Similarly, you can check it for here, that we can solve this pattern just like that and just get the answer as 1 by 2 as our common difference D. Okay. So, note it. Okay, so in the first example, you can have that the value 4, the common difference is 4. Okay. Now, write the first three terms in each of the following sequences defined by the following. An equals to this and N equals to this. So, if you carefully will see these two sequence, okay, these two are sequence, not an AP, because if you have a look at that, this is linear, but this is not linear. So, that can be a series but not an AP. So, if we talk about the first one here, the first one, AN equals to AN equals to 3N plus 2. So, we have to write the first three terms. That means put N equals to 1, 2 and 3. If you put N equals to 1, so A1 will be equals to 3 multiplied by 1 plus 2. A2 will be equals to 3 multiplied by 2 plus 2 and A3 will be equals to simply 3 multiplied by 3 plus 2. So, now you can just solve these and that will be 5 and here that will be 6 plus 2, 8 and here that will be 9 plus 2, 11. Okay, now the common difference is 5 here, 8 minus 5. 3, 11 minus N, 3. So, common difference is 3 here and if you look at it, because it's linear, so the coefficient of the N, that is 3, will be the common difference 3, which is shown here. If we talk about the second given equation, that is An equals to N square plus 1. So, if An equals to N square plus 1 here, then to have the three terms will just write An, that will be 1 square plus 1, A2 will be 2 square plus 2, 2 square plus 1 and A3 will be equals to 3 square plus, and that will be 1 plus 1, 1, sorry 2, okay. So, 1 plus 1, 2, 4 plus 1, 5, similarly 9 plus 1, 10. Now, the common difference is 5 here and here common difference is 3. Common difference is not same because this is not a linear equation. That means this is not in AP. This is only a sequence of series, you can say. Okay. So, note this. If the question was something like that, to identify which of the following is an AP, so you can just tick the first one Okay, because the second one is nth term and it is not in linear, it's not in linear equation in M, and so you can say that this is not an AP, right? The nth term of a sequence is 3n minus 2. Is the sequence an AP? If so, find its 10th term. What we have to find? The nth term, the 10th term, if the nth term of a sequence is 3n minus 2. Okay. So, nth term given. Okay. So, is it in the AP? This is linear. So, if this is linear, that means this is in AP. So, yes, it is in AP because n is having linear or having power maximum power as 1. Okay, or you can just simply say that this equation is because the an is linear. Now, the nth term will be equals to 3 multiplied by, just put n equals to 10 here, minus 2, and that will be 30 minus 2 equals to 28. So, this 28 will be your answer. It's an AP. Why? Because it's linear and the nth term will, 10th term will be n equals to 10, whatever value you will be getting, that is 28 here in this case. Now, it is evident from the above example, you can say that the sequence is not an AP. Always it's not true that sequence will be always and always an AP. That's not possible if its nth term is not a linear expression in n. Okay. So, which term of a sequence is 4, 9, 14, 19 is 124. Which term? That means we have to find out what n is. Now, what is given here? This is to find, and what is given is A given, the first, the difference, common differences, second, minus first term which is equals to 4, which is equals to 5. So, D is given, A is given. Now, it's saying that 124. So, we have given Tn equals to 124. What formula we are having? Simply Tn equals to A plus n minus 1 D. Now, put the values. 124 will be equals to A, which equals to 4 plus n minus 1 multiply by D, common difference D, which is here 5. Okay. So, that will be simply 120 124 minus 4. So, 120 equals to n minus 1 divided by 5 here. Okay. So, you can just say that n will be equals to 120 upon 5. That means 2, 5. So, 24 plus 1, that will be 25. That means 25th term of given AP will be 124, right? So, this is the answer. Noted. Now, let's have the last question of today's lecture. So, if m times mth term of an AP is equals to the nth times its nth term, show that the m plus n term of an AP is 0. So, given, what is given? M times mth term equals to n times nth term. What this means that m multiply by mth term. What is mth term? Tm will be equals to what? A plus m minus 1. The place of n will write m here because it's mth term. So m minus 1 d. Here n times nth term, and we are very familiar with the nth term, that will be a plus n minus 1 d. So just solve this equation, that will be m a plus m d minus d. Here that will be n multiplied by a plus n d minus d. Okay, now that will be am plus m square d minus md. Now transpose this complete term here. That will be an minus n square d plus minus, and then this term will be transposed here. So that will be nd plus nd equals to 0. Now we can have these two terms, a common, m minus n remaining. Similarly, if we took these two terms, m square plus m square d minus n square d. So if you will take d common, you will be remaining with d multiplied by m square minus n square. M square minus n square is what? M plus 1, m plus n, m minus 1. M square minus n square equals to m plus n, m minus n and d. So I am taking common this m minus n. So here it will be plus m minus n. Okay. So that will be m plus 1. Right. Multiply by d. Similarly, if I will take these two terms, that will be minus m minus this term md, right, this term minus md and this term plus md. So if I am taking minus common here, that will be minus d common here, so that will be m minus n, and that will be equals to 0. Okay. Now this m minus n will cancel out. So that will be, come here, this side, that will be a plus m plus n d minus d equals to 0. Here, right. So if I am taking this common d, so that will be m plus n from this section and minus 1 equals to 0. Now this is our result. And now see what the question is asking. If m times mth term of an AP is equal to n times of its nth term, show that m plus n term of the AP is 0. So if I emphasis on that particular line, m plus n term. So m plus n term is what? A plus n minus 1. In the place of n, I am having m plus n. So m plus n minus 1 multiply by d. This term should be equals to 0 according to my question. So here I am having an a plus d m plus 1 minus 1 equals to 0. So m plus nth term of given AP is equals to 0. Hence proved. Okay. Now note it. Right. So This was the complete lecture today. We have solved some questions and we have talked about the summation of n terms. Okay, students, so take care of yourself, revise this lecture, and we will meet in the next lecture. Okay, bye-bye. Take care.